Hey guys, well, it's the last video for this unit that I'm going to be doing, and then Miss Logus will be taking over the next one. We're going to be working on polynomial inequalities, and what that means for us is we're going to have to deal with these guys. And remember all that other stuff that we did before, where we had to like do this factoring stuff? Yeah, we're going to do all this, but with inequalities. That sounds fun. I'm excited. I know you're probably excited too. So, yeah, we're going to go and get going. I'm on this problem. Let's go ahead and get you to solve this on your own. This is a little bit of a review. Make sure you graph this as well. Pause the video now and resume when you're all done. Okay, so I'm guessing that you tried it. I hope that you tried it. It was a little bit of a review. Add 5 to both sides. You got 3x is less than or equal to 7. And then divide that 3 over. You got x is less than or equal to 7 over 3. That's a 3 in case you can't tell. And then graphing on the number line looks like this. And hopefully you got this correct. If you didn't, I would have advice for you. Go to the MRC. Go to the MRC. If you did not get this problem, go to the MRC. And you know who's in the MRC is Brandon Yip. There is Emma in the MRC. She's usually in there. Morgan is in the MRC. There's a lot of people in the MRC. I think there's a Grace. Somebody told me to say Grace, who also goes to the MRC. Anyway, let's get back to work here. Let's go and solve this problem. X squared plus 2x equals 3. I'm going to go and do this one with you for the sake of time. We'll subtract the 3 over to the other side. This looks like it's factorable as an x plus 3 and an x minus 1. This means that my roots are x equals negative 3 and x equals 1. And you're saying, there's no inequality there. That's true. You're 100% correct. Now we're going to do this part. We're going to actually look at the steps to how you solve a polynomial inequality. And the way you're going to solve a polynomial inequality is you're going to look at these few steps. First, you find the critical numbers. The critical numbers are the roots. Any real roots that you come up with, those are going to be defined as the critical numbers. So for this particular example, we have x equals negative 3 and x equals 1. Those are the critical numbers for us. Second, it says this thing that says do a line test. Now, this does not mean to actually draw a line and test it. That doesn't make sense. That's a silly thing to suggest. What it does mean, however, you're going to go and draw a line. You're going to put a negative 3 down, like on a number line. You're also going to put down a 1. What we're going to do is we're going to do a line test. I want to know on the left of negative 3, in between these two parts, and on the right of 1, whether my sign for this polynomial is positive, negative, or 0. Now, if this isn't making sense yet, I'm going to have it make sense in just a minute. We had x plus 3 and x minus 1. And let's just set that equal to 0 for a second. If I plug a number in on the left, and this is what the line test is, if I plug a number in on the left, like let's say if I plug in negative 4. If I plug in negative 4 here, well, I get negative 4 times a positive 3, and a negative 4 minus 1. I get negative 4 minus 1, that's a negative 5. Negative 4 plus 3, that's a negative 1. And I multiply those together, and I get a positive number. In fact, if I take any number, and on the left side of negative 3, I guarantee you that I am probably going to get a positive number always. So if we try like negative 100, let's say, some number on the left side of negative 3, if I try negative 100, negative 100 plus 3 is going to be a negative number, like negative 97. And then if I kept negative 100 again, negative 100 minus 1 is negative 101, which is a negative number. And when I multiply that negative times the negative, I get a positive. I have to repeat this step in between negative 3 and 1, and I have to repeat this step on the right side of 1. So a line test, pick a number that falls in the interval to determine sign. So let's try -3 to 1. What would be a good number that I could pick that could be plugged in for -3 and 1 in between those two numbers? 0. Right. Thank you. That was my alter ego. Now, if I put in 0 here into this equation again, into x plus 3 and x minus 1, what do I get out? Well, I get 0 plus 3 times 0 minus 1. That's going to be a positive 3. That's going to be times a negative 1. I get a negative 3. And I can expect any number in between -3 and 1, when I plug it into x plus 3 and x minus 1, I'm going to get a negative number out. We'll go ahead and try one more. Let's go ahead and try on the right side of 1. I'm going to plug in 2 because that's just going to be a little bit easier to use. I don't want such big numbers. I'm just going to pick a nice small number. So if I plug in 2 plus 3 and 2 minus 1, it looks like both of these are going to be a positive. I get a positive. Now, what does this have to do with the actual problem? Well, it says that I want a positive number. In other words, if I actually took this inequality and I did x squared plus 2x minus 3 is greater than 0, that means that this number on the left side needs to be greater than 0. In other words, I need a positive value out. The positive values happen on the left of -3 and on the right side of 1. So my solution, all the numbers up until -3 and all the numbers on the right side of 1. Let's try the next problem. I have the instructions on the right-hand side for you here. You're going to want to find the critical numbers. You're going to do a line test, and you're going to write solution intervals. I would try to pause the video now and see if you could actually solve these on your own, or try to make a start in it. So that way when you resume the video, you'll be able to see some steps that maybe you were able to get and maybe you weren't able to get. Pause the video now, please. Okay, I am going to show you the answer. First, you're going to go and take that 16. We're going to move it to the other side. So we'll get x squared minus 6x, and we're going to do a minus 7, and that's going to be less than 0. Notice that this is factorable. So I could do x minus 7. I can also do x plus 1. This is still all the same step of finding the critical numbers. I noticed that if I set these equal to 0, these factors, I get x equals 7, and I get x equals -1. Now, those are my critical numbers. What's next? Do a line test. Okay, so I'm going to draw my line. I got -1 here. I got 7 here. I got to pick a number on the left of -1 and see what the sign is. So I'm going to pick a number like -2. I'm going to plug it into either one of these. I'll probably plug it into this one because it's a little bit easier to evaluate. -2 minus 7, -2 plus 1. I got a negative number, and I actually don't really care about the value. I'm just interested in the sign of this because I want to know where the numbers are going to be less than 0 for this inequality. I got a negative number, I get another negative. When I multiply those together, I get a positive value out. Let's pick a number in between -1 and 7, like 0. If I plug in 0 into the factored form, I get a negative times a positive. That's going to be a negative. There's a negative number in between there. I'm going to repeat this process for 7, so I'll pick 8. If I plug in 8, I got 8 minus 7. I got 8 plus 1. It looks like both those numbers are going to be positive, which gives me a positive value here. That's the line test. All of this part is the line test. Finally, let's go and write the solution intervals. I want the factored form to, when I plug in a value for x, to be less than 0, which means negative. Well, the only negative that comes up is right here. So my answer, -1 to 7. I'm going to use open parentheses here and not brackets, because remember, if I plug in -1 into this equation, I will actually get a 0 out. So since I don't want to 0 out and I only want negative numbers, I just want in between -1 and 7, not this. If you wrote it this way, the question would have to say, just for your reference, it would have to actually equal 0, because when I plug in -1, I get equals 0, and same with 7. Your answer's in the box, though. You're going to need to pause the video to try this problem on your own. Go to pause the video now, please. Okay, hopefully you had a good shot at it. I hope you realized right away that this was factorable, and if you factored it, you get x squared minus 4 and x plus 2. But the nice thing about this is we get a plus and minus 2 here from x squared minus 4. X plus 2 gives us a -2. And actually, we have a double root at -2. So my roots are -2 and 2. And I did a line test, and I used the colors here to show you what's going on. So I plugged in -3 on the left here. I got -5, which was less than 0, so that's a negative. I plugged in 0 for in between -2 and 2. I got a negative number out, so that's going to be negative. I did the same thing on the right side of 2. I plugged in 3. I got a positive number out. That's why there's a positive there. I'm looking for all the values that are less than or equal to 0. So all the numbers less than 0 are the negative ones, which is all the way up until -2, and also up to 2. So it's actually all of these numbers here. Notice there's a bracket here at 2. So what it's saying is that if I plug in any number into this polynomial, or even at the start, if I plug in any number in this polynomial that is from -infinity, like -1,000, -1,000,000, and I even plug in 2, any of those numbers will actually be less than or equal to 0. Let's go on to the last problem. Give it a shot. And if you want a hint, it is factorable. Please pause the video now. You'll have the answer up here and once you resume. Okay, guys. Let's see how we did. I'm going to put a screen on this. And number 1, you should have seen that it was factorable. If you didn't see that, it does factor into x squared minus 9 and x squared minus 3. This is a very quadratic-like expression. One thing I'm going to note, you had to move the 27 to the other side. Once you get this in factor form, you get a plus 3, a minus 3 from this first factor here. We get a plus square root 3 and a minus square root 3 from the right factor. Now, after that, it's just a lot of plug-in numbers. So I had multiple intervals to test here. I had to plug a number in on the left side of -3. I also had to plug in a number on the right side of 3. So when I plugged in +4, I ended up getting a positive value out. Same thing with -4. I was still able to get out a positive value. To go in between the roots, like -√3 and √3, I plugged in 0. 0 gave me a positive value out. So that's why in between -√3 and √3 is positive. Same thing with plus and minus 2. I used a 2 here to plug in between these two values. And the bottom line here is I'm looking for numbers that yield positive results or 0, which means that my final answer here is going to be -infinity to -3, -√3 to √3, and 3 to infinity. Make sure that you are watching the brackets. Those are important in your final answer. And other than that, Hope you guys enjoyed the video. If not, you can find me in the MRC.